Alright, so this time we're gonna continue on with we're gonna go with the systems. So we already have an entity and we already have some component that holds some data, right? So this time we want the component to start doing something. So a system in Ursa is essentially just a mono behavior. Almost doesn't have anything additional to it. So all we do is just create a rotator system. It will rotate our object. Alright, so due to how Ursa works, it encourages you to not use Unity events like update. Instead, it encourages you to use ordered update. And what it does is, if say you have, what did I do here? Okay, so I'm creating here a rotator, adding a rotator system to it, and I'm duplicating it quadrillion times. Now, due to because of the system executor that we have here, the system are executed from top to bottom. So we can drag them around, and depending on their position, they will fire updates, different events based on their position. So because of how entity component system works, this essentially replaces the script execution order, but it does it in a more robust way that is dynamic and doesn't require you to recompile all the time and stuff like that. So alright, now we would say void ordered updates, and here the magic begins. Now we know that in the scene we have some stuff, right? So let's assume we don't know anything about the scene, but the system itself is interested in rotator components because it's a rotator system. So I would have to introduce you a new concept that Ursa has, and that concept is a pool. Typically, when you think of a pool in game development, well, in most entry-level tutorials, a pool is something like a bunch of reusable components, or reusable objects that just get, instead of being destroyed and recreated, are just constantly reused and reinitialized. Alright, so in the pool, coffee cup here, in the Ursa pool, a pool is a way to register our components that are newly created. A newly created component will send itself to the pool, and they will be there in a list, reside there, the same components of the same type. So if this component is a rotator, then we would have a pool of generic type rotator, and through this pool we could access the list of all currently existing in the simulation components. So it is a way to store a flat list of everything that is currently in the game efficiently, with high speed and with different optimizations. And in general, this is for advanced people, this is our service locator. You can think of, despite it locates existing data in the game, it doesn't really access any systems in itself, and it's a static thing. And despite it does has some logic when it is created, in general just a static generic class that is statically accessed. So let's say we assume that we have some rotators in the scene. So we would have we want our list of rotators, so of all the rotators in the scene. So I would ask my pool of the type rotation. I would say, like, alright, give me all the rotation components currently in the scene. So from now on, all I'm doing is I'm iterating over all the rotation components, and we modify them somehow. So let's see what we have inside. So as far as I recall, we have something like current rotation. Yeah. So let's just add time delta to it. So time delta and add some value so it's not really small. Right. So this is basically it. Upon pressing play, if we find our whoever has it, there you go. You can see that it's getting modified, and the system already modifies it. Now here is our object that has our component rotation. Now if we duplicate this object, we can see now both components are being updated. If we keep multiplying them, deleting them, it doesn't change anything, because every frame it still iterates over all the components in scene that are rotation. It doesn't care about anything else. It doesn't care about how these objects are structured, what's inside of them, what's outside of them, near them. All it cares is actually just this component. Now we can go further and we can say transform. Let's do it old vector free rod equals R, because our component is a mono behavior. It has access to the transform of the object. So right here we can actually modify the transform as well. Rotation, Euler angles. And now we say rotation X plus equals, say, R current rotation. Or just let's say it equals it, so it's gonna be easier. And now R transform rotation equals quaternion Euler rot. So now a simple modification, our object starts rotating. And again, we duplicate this object and it keeps rotating. All of the subjects keep rotating. Now, what have I done? Was it rotating so fast? Oh, it's probably because it broke the sound barrier. It's okay, it happens. Actually, it happens because I'm assigning this rotation here instead of multiplying it or whatever, or adding it. So I won't even actually remove it. I'll just keep adding that rotation. So alright, now this is one use of the pool. The pool again is a static class. It's all our things that we have here, entities, components, are static, are global, and the pool doesn't really do anything. All the actions it performs is on registration and on creation, so it is efficient and doesn't create overhead. Now, actually, I'll stop here.